My dear students, let me welcome you all to the first part of the final revision of physics. Without losing any time, let's cut to the chase. Let's get started. First question, okay. In which direction must the wire be moved in order to induce current in the direction shown in the opposite figure shown to you? There is something very important. I want you to know it. When motion induces current, we apply Fleming's right-hand rule. When current causes motion, we apply Fleming's left-hand rule. So in this particular case, we'll apply Fleming's right hand, okay? The question is, will it move upwards, downwards, towards the North Pole, or towards the South? You have to apply Fleming right, and it will be upwards. Okay, second choice, process of adding impurities. Yes, adding impurity atoms in controlled amounts to an intrinsic semiconductor to increase its conductivity is called injection, doping, toxicity, excitation. Of course, it is doping. Thank you very much. Next choice, okay, the opposite figure, the figure represents a current carrying wire in a magnetic field. The direction of the conventional current is out of the paper. The force is the force which will act. Here we'll apply Fleming's left-hand rule, okay? The force is upward force, downward, okay? From south to north, no correct answer. Of course, when we apply Fleming's left, we'll get an upward force. Okay, so the answer is upward force. Another question, which of the following is not trivalent impurity atom? This is all easy question. Boron, indium, gallium, and phosphorus. Of course, it is phosphorus because it is pentavalent, yes, pentavalent impurity atom. So the right answer is phosphorus. Next choice, here we've got two parallel wires, AB and CD, and your attention are connected to batteries, are shown in the figure. AB is fixed, is not allowed to move when both switches are closed. Okay, wire CD will move in what direction? Well, it depends if we've got repulsion or attraction. Just let me remind you with something. AB is not allowed to move. CD is the wire which is allowed to move. Your attention, please. Okay, so we have to determine the direction of the current, of the conventional current that goes from the positive terminal. Okay, so this is the direction of the current. Choices we've got: move to the right, okay, move to the left, okay, move in a direction out of paper, direction into the paper. Here we expect to have repulsion, so it moves to the right. Okay, another choice. Energy gap between valence and conduction band is overlapped. Okay, is overlapped means the material is, yes, a good conductor. Is it overlapped in insulators? It is in conductors, semiconductors, or none of the above. I've already answered it. It is in conductors. Another choice. Here we've got an ohmmeter that has a resistance 70 ohm. Okay? Resistance of the ohmmeter is 70 ohm. The value of the external resistance, which when connecting it to the ohmmeter, makes the pointer of its milliammeter reads 1/3 of its full scale deflection. Let me say it again. Okay, because I'll explain it. Ohmmeter having a resistance 70, we want to know the value of the external resistance to make the, yes, it's milliammeter, reads only 1/3. Your attention, please. We should, yes, add a resistance, an external resistance, which has a value twice the value of the ohmmeter. Why twice the value of the ohmmeter? Such that the total resistance of the device, the new device, is, yes, tripled in this way. The current is decreased to 1/3 of its initial value. So we have to add a resistance which has a value twice as great as that of the ohmmeter. So what about the choices? It is 100, 210, 140, 70. Twice 70 is 140. Okay, another choice. The bulb which is lighted in that found in circuit. We've got 3 circuits here, yes, that contains diodes. We want the bulb which is able to light. Is it in A, B, or C? In circuit A, it is reverse biased. Positive, yes, electrode is connected to the negative. It is reverse biased. Okay, P is connected to the negative. Okay, so no current flows in the first one. In the second, we've got 2 diodes connected in series, and they are placed in opposite directions. So one of them will be reverse biased. Yes, it will act as an open switch. No current will flow. And the third, they are connected in parallel. Okay, so one of them will act as a closed, and current will be able to flow. So we expect it. Is it A, B, C, or none of them? Of course it is C. Okay, another question, another choice. A coil of area 40 centimeters squared is placed in a magnetic field. Area is given here 40 centimeters squared. Centimeter squared should be converted into meter squared times 10 to the power of negative 10 power negative 4. Centimeter squared should be converted into meter squared. It is multiplied by 10 to the power of negative 4. Magnetic field density 0.2 Tesla. Yes, placed in a magnetic field 0.2 Tesla such that the plane of the coil is perpendicular to the field. Calculate the magnetic flux through the coil when rotated from its initial position through an angle 60. Choices: 8 times 10 power negative 4, 4 times 10 power negative 4, 6.9 times 10 to the negative 4, or something. Here we've got something very important. The choice here, the question asks about magnetic flux, phi. Okay, the initial position here is perpendicular to the field, so the field is maximum, and by rotation it will decrease. When you're starting with maximum and by rotation it decreases, we'll use cosine. When you're starting with 0 and by rotation it increases, we'll use sine. Here the plane is placed perpendicular to the field. All the flux passes through it, so it is maximum. And by rotation it will decrease, so we'll apply cosine here. Phi equals AB cosine the angle given. Okay, so the answer is 4 times 10 to the power of negative 4. How? Phi, as I said, equals AB cosine theta. Great. And all you have to do is to substitute, and the answer is 4 times 10 to the power of negative 4. This is very important piece of information. Okay, another choice. Rectangular coil of magnetic dipole moment 30 ampere meter squared. Okay, hangs in a uniform field of density 0.3 Tesla, such that the angle between the dipole and the field equals 30. Angle between dipole and field will use sine. Okay, when you use the formula of the torque, bien, okay, we'll use sine the angle. Okay, calculate the torque acting on the coil in that position. Is it 4.5, 9, 7.79, 2 times 10 power negative 4? No correct answer. Okay, 4.5, the question is how? As I said, torque equals BIAN sine theta. Magnetic dipole equals IAN. This means IAN is given one shot, okay, to be equal to 30. So we'll apply field 0.3 times 30 equals 9, sine 30 equals half, so the answer is 4.5. Okay. Another question. Galvanometer has a resistance R. To reduce the sensitivity of the galvanometer to 1/5 its original value, 1/5 its original value, it should be connected to a shunt of resistance, yes, equal to R over 5, R over 4, R over 3, R over 2, or R. Okay, it's all easy for you. To decrease it to 1/5, it is R over 4. To decrease it to a quarter, R over 3. Okay, just remember this. Okay, another choice. Ammeter has a resistance R. Its microammeter reads or gives its full scale deflection when a current I passes through the coil. The value of the external resistance needed to make the pointer of its microammeter deflect to half the initial is R, 2R, 3R, 4R. Okay, this is very important. To give half deflection, so the device is connected to another external resistance which has the same value as the value of the ammeter. So the right answer is, yes, of course it is R. Remember this because this is very important. Holes in N-type semiconductors are called, I guess it's all easy, majority charge carriers, minority charge carriers, barrier potential, or depletion. Of course, it is minority charge carriers. Okay, a p-n junction is a device, non-ohmic, okay, bilateral device, linear device, none of the above. Okay, this is very important. It is non-ohmic. What does it mean? p-n junction is non-ohmic device. We don't have a direct relation between voltage and current, so we call it non-ohmic. Okay, so the right answer is non-ohmic. Another choice, yes, what we've got here. A state in which electrons remain excited for much longer than that in the normal excited state is called a stable state, ground state, okay, metastable state, excited state. Of course, it's all easy for you. It is metastable, yes, state. Another choice, imparting of light energy to the active lasing medium, active medium we call it lasing medium, to excited is known as, given of this energy is known as thermal pumping, yes, chemical pumping, optical pumping, and none of the above. We are given light, so it is optical pumping. Another choice, the dominant color of the radiation emitted from a glowing black body depends on, does it depend on temperature, kind of the object, and surface area of the object, or none of the above? Yes, it has nothing to do, the color of the glowing object has nothing to do with the, yes, kind of the object. It only depends on temperature of the object, okay? Just remember, bear this into your mind. It depends on temperature of the object. Okay. Each part of a hologram, this is very interesting choice, contains information about the entire object, a particular part of the object, an important part of the object, and the front side of the object. It contains, yes, information about the entire object. Okay, this is very important question. Okay, another question. The brightness of the bulb shown in the figure. Okay, the moment the key is opened, okay, what will happen to the brightness? Increase, decrease, is still the same, unchanged, unaltered, no appropriate answer. Okay, as a matter of fact, it will decrease. Why? When opening the key, a forward induced current will be induced in the second circuit, in the secondary circuit. Forward means having the same direction as that in the first. And the first is flowing downwards. So we'll expect a current that flows downwards in an opposite direction to the current flowing to the bulb. So it decreases. Okay, these are very interesting questions. Okay, in what direction should, this is very tough question. In what direction should the magnet be moved such that electrons in wire YZ flow from Z to Y? Your attention, please. We are used to conventional current, the current which is regarded as the movement of positive charges. But now in this question, it asks about the flow of electrons. It is the opposite to the conventional. Okay, when we approach the North Pole, what happens? N pole is produced and current flows from Y to Z. The conventional flows from Y to Z to flow in the coil in anti-clockwise direction. And in this way, electrons will flow from Z to Y. So, in what direction should the magnet be moved such that electrons move from Z to Y? The choices, this is very interesting, I said, and it is, yes, it requires a lot of concentration. The magnet should be pulled away from the coil. The magnet should be plunged into the coil. Okay. The magnet should be moved upwards. The magnet should be moved downwards. As I said, the magnet should be plunged into the coil. Work function of a photosensitive material depends on, all right, temperature of the material, kind of the material, frequency, or none of the above. I guess it is known for you. It depends on the kind of the material. Okay. The curves that represent the intensities of radiations emitted by a black body at different temperatures, they are given a name, are called what? Vanes displacement curves? We don't have any such a thing. We've got Vanes displacement law. They are called Planck's distribution curves, line spectrum, or none of the above. Of course, they are called Planck's distribution curves. Okay. And another choice, type of X-ray. Type of X-rays used to detect fractures, breaks in bones. Do we have to use hard or soft or of very low frequency or none of the above? We should use X-rays that have a high frequency range to be able to penetrate bones. So it should be, yes, hard. So the type is hard X-rays. Important choice. The kind of spectrum emitted by a glowing black body at a different temperature. Is it a continuous spectrum, line spectrum, absorption spectrum? All options are correct. Let me tell you something. Any glowing black body will give continuous spectrum. It has nothing to do with the kind of the object. Okay? So the right answer is continuous spectrum. Another choice, systems, very important questions, very hidden piece of information. Systems that detect and determine the distance of a target by using a short pulsed laser. These systems, yes, use the pulsed laser to illuminate the target and then calculate the time it takes to return. Okay, what about these systems? They are maser, radar, ladder, or no correct answer. Maser, by the way, is laser in the microwave region. Okay, the answer is yes, ladder. It is ladder. This is very important thing. We use laders in military uses. They are systems that detect and determine the distance of targets. Keep this, bear this piece of information into your mind. Okay. Another choice, when very fast-moving electrons are rapidly decelerated, the produced rays are gamma, X-rays, alpha, and beta rays. Of course, yes, the way to produce X-rays, yes, electrons are accelerated, are highly and rapidly accelerated. We increase its velocity, and they are all of a sudden decelerated. And this energy of the electrons is converted into photons having high frequency in and giving X-rays. Okay. Another choice, ruby laser is it 2-level laser, 3-level laser? This is very important question. This is very important question. Or 4-level or 5-level laser? Of course, it is 3-level rays. Of course, it is 3-level laser. This about ruby, but your attention. Helium neon laser is a 2-level laser, 3-level laser, 4-level laser, 5. Of course, it is 4-level laser. Okay. Pumping source in helium neon laser is, this is very important question, is chemical pumping, electrical pumping, electric discharge, light, or mechanical? Of course, it is electric discharge. Another question, the active medium, we call it the lasing medium in helium neon is it helium, neon, or helium and neon, or none of the above? This is very important piece of information. It is neon, of course. Okay, another question. In which region laser emission occurs in helium neon laser? In which region? Okay. Is it an infrared region, visible region, or ultraviolet, or none of the above? Of course, it is visible region. Another choice. Frequency of X-rays. Your attention, please. It asks for frequency, not wavelength. And the question is, how I can get frequency? I know the wavelength. Use the formula C equals lambda nu. Okay, the choices, 10 to the power of negative 13 to 10 power negative 8 hertz. This could be the right answer if it is meter. Okay, if the question was about the wavelength, okay. And 3 times 10 to the power of 21 minus, or ranging to 3 times 10 to the power 21, ranging to 3 times 10 to the power 16 hertz, 10 power negative 10 ranging to 10 power negative 15 meter, 10 power 2 ranging to 10 power 9 meter. Of course, C and D definitely wrong because the unit is not unit of frequency. And by using the formula I said, it will be number B, 3 times 10 to the power of 21, ranging to 3 times 10 to the power 16. Okay, another choice, the pumping source in ruby laser is chemical, electrical, light, or thermal. Of course, it is light. Another choice, the ratio of helium to neon in helium-neon laser. Is it 1 to 10, 2 to 13, 10 to 1, 3 to 11? Of course, all of you know it. It is 10 to 1. Okay, another important choice, the least time at which the value of the current equals its effective value in an AC dynamo, okay, is 2.5 times 10 to the power of negative 3 seconds. Effective value, time of the effective value, least time of the effective, equals 2.5. The angular speed of rotation of the coil of the dynamo equals 50, 0.02, 314.28, no correct answer. The answer, the unit rad per second. How to do such a problem? It is 314, but the question is, time of effective means that we've got the angle equals 45. 45 equals, this is an angle, 2 pi ft, okay, pi 180, okay, in this way time is given, I'll be able to obtain frequency. Still I need something. I want 2 pi f, which is the angular velocity, omega. Frequency, we managed to obtain it, equals 50 hertz. Now omega equals 2 pi f, but pi here, because the answer is given in red, should be 22 over 7, okay? Frequency 50 by 22 over 7. The answer, as I said, 314.28 rad per second. Okay, yes, we've got branching, and the value of the current is it 1.5 ampere, 1 ampere, 2 or 3 amperes? It is 1. The question is why? Okay, to answer this, we'll take it from the last branching. Okay, we've got 3 and 1 ampere coming out from the last node. So the entering current should be 4 amperes. 4 plus 1 will give 5 amperes. 5 amperes originally are 2 and 2 and something. That something is 1 ampere. Okay. Okay, this is very simple question. Another question. An ideal PN junction is one which behaves as a perfect when forward biased. PN junction when forward biased behaves as a conductor, insulator, resistance material, or none of the above. Of course, it acts as a closed switch. It is a conductor. Okay. Another choice. The leakage, the drift current, the drift current in a crystal diode is due to minority charge carriers, majority charge carriers, or junction capacitance, or none of the above. Yes, drift current is due to minority charge carriers. In this way, we've come to the end of this edition. Before I leave, I just want to say something. I know you are worried, you are anxious, and you're not alone. Everyone gets stressed by exams, and physics exams are very stressful. But I want you to know something very important. Stress improves performance, but only to a certain point. If it exceeds a certain point, it will be so harmful. So manage your stress, control it, expect the best, and go to get it. All the best for you. Thank you very much.